Hello students, welcome to the video on Class A series fed power amplifier. Actually under Class A, we have two types of power amplifiers. Those are, under Class A we have two types, series fed and transformer coupled. The series fed is also called direct couple. Now I will start Class A series fed power amplifier. This is a circuit of Class A series fed power amplifier. The series fed power amplifier is also called direct couple power amplifier. Class A direct couple power amplifier. Okay, what is the reason for this name? See the load RL. The load RL is in series with the collector or in series with the output terminal. That is the reason it is called series fed power amplifier. And the other name is, the load is directly coupled to the collector without using any coupling mechanism or any other coupling device. The load is directly connected to the output, hence it is called direct coupled Class A power amplifier. Okay, we know the purpose of power amplifier. Okay, it will handle large signal. And the output of the power amplifier always feeds the loudspeaker. Okay, means the load for the power amplifier is loudspeaker. Instead of RL, you can keep a loudspeaker. Fine. What we are going to analyze this, what we are going to study in this concept, we are going to derive the efficiency of Class A series fed power amplifier. What is the concept of efficiency? Initially, the power amplifier takes the DC, okay. With that DC, it sets the operating point, it sets its biasing. After that, it will take this input signal and it sends that input signal to the output, and that output is connected to the loudspeaker, okay. Means, how much amount of DC power it is taking and how much amount of AC power it is giving at the output side. These two are related with the efficiency. What is the efficiency formula? AC output power divided by DC input power. Okay. So if that efficiency is high, so when the efficiency is more, what we can say? We can say that this power amplifier is delivering maximum amount of the AC signal to the load. Then only we can say the power amplifier is very efficient power amplifier. Okay. So in all the power amplifiers concepts, we are going to derive its efficiency. Okay. So for that efficiency concept, we are going to find DC power as well as AC power. Okay. Yes, now let us start analyzing this Class A series fed power amplifier with its operating point. Yes, we know the operating point for Class A is the middle of DC load line. Okay. So the Q point is, so that is a very important point. Now we'll start one by one. That is finding DC input power and finding AC output power. So for that we'll start with the DC operation. What's the meaning of DC operation? See the circuit. The circuit consists of AC signal as well as DC signal. Okay. So in the DC operation, you have to assume that you are not giving any AC input signal. So if you won't give any AC input signal, if you make it equal to 0, then your circuit consists of only DC supply VCC. Now what will happen? All the values of the currents and voltages becomes the DC values. Okay. So what are the currents and voltages here? So this is the current IC and this is the current IB and this is the voltage VBE. Between base and emitter you have the voltage VBE and between the collector emitter we have the voltage VCE. Now in this DC operation we are going to find the quotient point values. Okay. So that's the thing we have to find first. Yes, how to get in the concept of load line, I explained that to get the Q point, first you have to find or you have to get the value of IBQ. Okay. So in the same way here also, you have to find the value of IBQ. Okay. So where is your IB? See this is your IB. See this is the IB. From this it is flowing like this. Okay. So how to write IBQ? Because it is the DC point, DC operation. Yes, you must write directly IBQ. What is IBQ? Simply you apply KVL. Okay, so from this, the current starts here, VCC, it starts here and it goes like this. So, what is IBQ? Simply by using the potential difference concept also, you can write IBQ. This is the resistance RB. RB other end is at VCC and the current starts from VCC. So, it is VCC minus, okay. What about the other end of RB? At the other end of RB is at base and base is at the voltage VBE. So, it is VCC minus VBE by, what is its value? Resistor value RB. Okay. Yes, you know that the Q point is in the middle of the DC load line. Means the Q point is an active region. So, you can take this VBE as 0.7. 0.7 volts. This 0.7 is nothing but VBE active of your transistor. Then, after getting IBQ, then how to find ICQ? ICQ is nothing but beta into IBQ. Okay, we all know very well about this formula. Then, another point is that is VCEQ. These two are the coordinates of the operating point. VCEQ. How to find VCEQ here? We already know the KVL. The output KVL. What is the output KVL? You have to start from VCC. Yes, start from VCC. VCC is equal to, yes, ICRL plus another voltage is VCE. So what is VCE? VCE is VCC minus ICRL. Simply you add another suffix Q. Yes, this is Q. So first find ICQ from IBQ. Then yes, VCEQ can be found like this. So what is VCEQ totally? It is VCC minus ICQRL. Okay, then from this you can write the load line also. What is the load line? IC is equal to minus 1 by RL into VCE plus VCC by RL. Okay, so this is totally the load line. What type of load line it is? It is the DC load line. DC load line. Okay. Now the last point under DC operation is DC input power. Okay. Yes, here after getting ICQ and VCEQ, yes, means we got the operating point values VCEQ and ICQ. Fine. Next, DC input power, PDC. What is actually power? Voltage into current. PDC, DC input power. What is the DC input, DC voltage input we are giving? We are giving VCC. So it is VCC. That is the maximum DC input voltage into current. What is the maximum current here? Okay, what is the maximum current in our circuit? It's nothing but ICQ. Fine. So this becomes the DC input power. This totally comes under the DC operation. Okay. Yes, we just find all the quotient values of currents and voltages and we also got DC load line. Now we'll move to the AC operation. Yes. AC operation starts with application of your input voltage. So when you apply AC signal, what will happen? All these currents and voltages, see this IBQ, ICQ, VCEQ varies exactly like your input signal and in the form of input signal, but with an average value of the DC values. Okay, your IB varies like your input signal with an average value of IBQ. IC varies like your input signal with an average value of ICQ. VCE varies in the form of your input voltage with an average value of VCEQ. Okay, so now I'll draw the graph related to this class A series FET. Graph related to the class A series FET power amplifier. So this is the load line. And here I want to tell you one point. What is the DC load line equation? We got IC is equal to minus 1 by RL into VCE plus VCC by RL. Okay. What about AC load line? Here, even after the application of input signal, yes, the circuit remains same. Continuously the current IC is flowing through RL. So there is no change in the expression of the load line. Hence, the AC load line is also IC is minus 1 by RL into VCE plus VCC by RL. Okay. So that is the reason now I am calling this line as load line. It is the DC load line as well as AC load line. Okay. Yes, the Q point is at the center of the DC load line and I applied the signal IB and this is the input current IB which is in accordance with your input signal Vn. Okay. So now just I extended the points and I extended onto the x-axis and I extended these points onto the y-axis. Okay. When you apply input current, so you're going to get two output values. One is output current, another one is output voltage. So this is the output current IC. Just to extend the points, you draw the IC like this. And so this is the output current IC varies in accordance with the input signal with an average value of ICQ. And this is the output voltage VCE. And we know the CE, this is in CE configuration. CE gives 180 degrees phase shift. So output voltage is having phase shift. It also varies like input signal but with an average value of VCEQ. Okay. Yes, now, yes, I am taking this as the peak voltage as Vm and this total as V peak to peak and this point as Vmax and this point as Vmin. Same way. And this is Im. This total is I peak to peak and this is I max, this is I min. Okay. And another important thing is what are the points here? DC load line intercepts. This point is VCC and this point is VCC by RL. Okay. So this is the graph related to the class A series fit power amplifier. Now we'll move to the AC output power concept. Okay. Then now coming to PAC. Here also the power is voltage into current. Okay. But this is the AC output signal. So what you have to go? You have to go for VRMS into IRMS. For as the output signal is AC signal. Yes, what is the VRMS here? Yes, this VRMS is the RMS value of output voltage. IRMS is RMS value of the output current. If you see voltage and current, both are full cycles, full sinusoidals. For full sinusoidals, what is VRMS? Vm by root 2. What is Vm? Peak value of voltage. And what is IRMS? Im by root 2. Okay, so if that is the case, then that will be Vm by 2. Okay, then how to write Vm? Vm is nothing but, say this, Vm in terms of V peak to peak is V peak to peak by 2 is nothing but your Vm. So it is V peak to peak by 2 into, yes, what is Im? This is Im. Im is nothing but I peak to peak by 2. By 2. Okay. So total it is V peak to peak into I peak to peak by 8. Okay. Yes, now you can write V peak to peak as Vmax minus Vmin. Okay. So yes, V peak to peak is Vmax minus Vmin and I peak to peak is Imax minus Imin. Imax minus Imin divided by 8. Okay, so that is your PAC. Yes, you can go for some other formulas also, but for the calculation of efficiency, this derivation is enough. See, you can write here Vm is actually Vm is IMRL. So if you substitute, yes, in the place of Im, substitute Vm by RL square by 2RL. Or if you replace Vm with IMRL, then it will be Im square RL by 2. Or you can write even VRMS as IRMS into RL. Okay. Then also it becomes, yes, you can write here VRMS square by 2RL. Or, okay, but this is enough to find the efficiency. Now, I'll move to the efficiency. What is efficiency? Percentage efficiency, that is percentage eta is AC output power divided by DC input power. Okay, so what is the DC input power? So this is the DC input power. Yes, what is PAC? PAC is AC output power. Okay, so percentage eta is PAC by PDC into 100. Okay, so what is percentage eta? Substitute PAC, Vmax minus Vmin into Imax minus Imin divided by 8. And what is PDC? VCC into ICQ into 100. Okay, so this is the general expression for percentage efficiency of Class A series fed power amplifier. Okay, then I'll find maximum efficiency of Class A series fed. How to find the maximum efficiency? Okay. To find the maximum efficiency, assume maximum swings for output current and voltage. What is the output current? This is the output current. Maximum swing means it must occupy the maximum area of the DC load line. Say this is the DC load line. For this Y part or output current part, yes, current part, this is the maximum swing. Yes, if you see the output current, this is the current, but it can be extended up to this. This is called maximum swing. Fine. Yes, what is the center value? The center value is nothing but ICQ. What is this value? 0. As the center is ICQ, put this point in terms of ICQ, it is nothing but, this point is nothing but 2 ICQ. Because your Q point is the middle of DC load line. Okay. Yes. So, yes, what is for the output current? Now, what is Imax? Yes, you can extend Imax up to 2 ICQ. So, it is 2 ICQ. Okay. And what is Imin? Imin is 0. Same way. Now, go for your output current. Yes, actually, this is the total output voltage swing. But our output is only this part. So, now you can extend Vmin up to this and Vmax up to this. Okay. And what is this value? This value is VCC. And what is this value? 0. So, you can extend Vmax up to VCC and Vmin up to 0. So, what is Vmax? Is VCC. And what is Vmin? 0. Okay. Now, if you substitute these 4 values into this, the maximum swings I'll write separately. DCE and IC. This is the load line. This is the point. This point is VCC. And this point is 2ICQ. Okay, this is your Q. So now, your output may be like this. VCE, it may be like this. This is the center is VCEQ, remember. And here, what's the current? The current may go like this. This is the current. IC. The center is ICQ. This is 0. These are the maximum swings. Now, to find the maximum efficiency, substitute all these values into this expression. So, percentage eta max, that is maximum efficiency, is equal to Vmax is VCC and Vmin is 0. So VCC minus 0. Then I max is 2ICQ, I min is 0. So 2ICQ minus 0 divided by is what is this value? 8 VCC into ICQ. Okay, so it is VCC into 2ICQ by 8 into VCC into ICQ. Here, remember, keep 100. Okay, so cancel, this will be 4. So it is totally percentage eta max is 1 by 4 into 100 is nothing but 25%. Okay. So this is the maximum efficiency of class A series fit power amplifier. Okay. So this is the theoretical efficiency actually. 25% is theoretical efficiency. Practically it is between 10 to 15. Okay. Means, see, what is the efficiency? PAC by PDC into 100. Then what we got? We got 1 by 4. 1 by 4 into 100 means 4 parts of DC power. We have 4 parts of DC power. But in that only 1 part is converted into AC part. Okay. All other 3 parts of DC power gets wasted. So what will happen to that wasted power? It gets converted into power dissipation. It gets converted into dissipated power. Okay. So the next thing is power dissipation. The power dissipated PD is PDC minus PAC. Okay. Yes, I explained here. Yes, we have 4 parts of DC power, but only 1 part gets converted into AC power. Means the 3 parts of DC power gets dissipated in the form of heat. Okay, so you get dissipated power or wastage of power or wasted power just by subtracting AC output power from DC input power. Then, how to get maximum power dissipated? That is PD max. When all the power gets dissipated, tell me. All the power gets dissipated when it is not used. Means when there is no AC input signal for the circuit. Then all the DC input power that we are giving gets wasted. So that is the reason PD max is PDC. Okay. So this is all about the analysis of class A series fit power amplifier. Okay. So the next class I'll explain class A transformer coupled power amplifier. Okay. Thank you very much.